this video, we're going to do a t-test for the population slope and also a confidence interval for the population slope. Okay, so we're using this direct mail data. An antique dealer recently opened a shop, and the shop is open to the public Tuesdays through Sundays. Direct mail, which is the unsolicited flyers and informational brochures you get through the mail, is the primary advertising outlet. Direct mailings are sent out every Wednesday, and we're going to use regression to determine if sales are related to the direct mail campaign. So the first thing that we would probably try is just to look at the relationship between direct mail and sales. So I'm going to follow the instructions for simple linear regression. These are on your reference sheet if you need them. Analyze, fit y by x. Sales is the outcome that I care about. I'm going to use the version in dollars. Direct mail is the X, and then I'm going to choose fit line. So I don't really see much of a relationship here, right? This looks like a pretty weak relationship. Only 6% of the variability has been explained, but there's actually a problem with this. If we look back at our scenario, notice that the direct mailings are sent out every Wednesday. So by the time they actually arrive, it's going to be too late to really influence the sales that week. If anything, it would probably have an impact the following week. So let's try taking that into account and jump. So instead of using the direct mail column as it is, I'm going to use a lagged version of that variable. So basically the idea is that I think that this week's direct mail is going to impact next week's sales. So I want that direct mail number for week 1 to be lined up with the sales number for week 2. Okay, so that's what we mean when we have a lagged variable. So I'm going to do this again, analyze fit y by x. Sales is still my response, but this time I'm going to put direct mail lagged as my explanatory. And I can see I've got a stronger association now. So now it's explaining about 42% of the variability. This is the model that I'm going to work with. All right, so we're going to take a look at this output. The question says, is there a statistically significant relationship between weekly direct mail cost, we're using the lagged version, and weekly sales revenue? So if we are talking about a statistically significant relationship, we're going to write the null and alternative in terms of the slope. So the null is that the slope of the population is equal to 0, and the alternative is that the slope in the population is not equal to 0. And because we're doing everything with the slope, we're going to look at the slope row in the output. In fact, if you want to mark out this other stuff for the intercept, we're not going to be using that. Okay, so we've got our slope. Let me show you how to calculate the t ratio or the t statistic. So this has the same basic form as other test statistics that we've learned. So a t statistic is equal to a regular statistic. So here we're going to use the slope minus the null hypothesis value. In this case, that's 0. And divide it by the standard error. So the standard error of the slope, that's something else that's given in the table. So if we do our slope, 52.8153, minus 0, obviously that doesn't make a difference. Divide by the standard error, 15.5738. Then we're going to get our t statistic, which is this 3.39. And if we want to see where that p-value comes from, we can use our t distribution. So this is a t distribution. The degrees of freedom is going to be n minus 2. And the sample size, I didn't write it down here, but if you count the dots, the sample size is 18. So in this case, the n minus 2 would be 16 degrees of freedom. And we're going to find our t statistic, find 3.39 on the graph. And we're going to shade everything beyond that. And then same on the other side, shade everything beyond. Okay, so my p-value is 0.0037. Okay, so this is a small p-value. When your p-value is small, that means that you have strong evidence. So we would always say strong evidence to conclude whatever our alternative hypothesis is. So in this case, that would be strong evidence to conclude that there is a relationship, right? Remember, if the slope is not equal to 0, that means that there is a relationship between direct mail costs and weekly sales. There is a relationship, wrong kind of mail. There is a relationship between direct mail costs and weekly sales. So far, all we have from the p-value is that we have strong evidence of a relationship. This doesn't necessarily tell us that direct mail makes a big difference, just that we have strong evidence that there is a relationship. So if we want to figure out how strong the relationship is, how much did the sales change, that's where a confidence interval could be helpful. So let's start off just by interpreting the slope. So the slope is the number here with direct mail, 52.82 since it's in dollars. So we would say as the amount spent on direct mail increases by 1, right, as the amount spent on direct mail increases by 1 unit, and in this case everything's being measured in dollars, so as it increases by $1, the weekly sales increase by this amount, $52.82 on average. So you can say on average, or you can say predicted to increase, but something to show that there's variability in that. Okay, so that's the sample slope, right? But we don't expect our population slope to be exactly equal to that. So for calculating the confidence interval for the slope, we're going to use this basic formula that you've seen before for confidence intervals. So we're going to start with our sample slope plus or minus our critical value. Again, this is quantitative, so we're using t star, and then multiplying it by the standard error of the slope. Okay, so let's plug into this formula. So we've got our sample slope, 52.82, and then to get the critical value, we're going to need to use JUMP. We're going to use that distribution calculator again. Sorry to interrupt myself. So it's definitely possible to calculate that t-star value. I do it in my other class because it's a coordinated class and I have less control over the curriculum. But honestly, I don't really think that it's worth the time. For one, because it comes out really close to the 2 multiplier that you would get for a 2 SE interval. So you can get really close just with that. And also because if you're gonna let software do part of it, why don't you let software go ahead and do the whole calculation for you? So that's why we don't focus on it in honors, but if you want me to show you how to use this JUMP add-in to calculate t-star, definitely let me know, I'd be glad to show you. Okay, so plus or minus 2.1199, and then multiply the standard error. Again, we're getting this from the output, 15.5738, and when we put that together, it's between 19.80 all the way up to 85.83. To get JUMP to calculate the 95% confidence interval for you, come down here to the parameter estimates and right-click on this table. It can be a little bit finicky, so make sure that your cursor's over the numbers when you right-click. And then go to columns, and it'll let you add a column for the lower 95%, and I'm going to do it again for the upper 95%. And you can see there I've got my values for the endpoints of the confidence interval. So this is a pretty wide interval if we think about how much payoff we're getting on this direct mail campaign. And that kind of makes sense because we only have 18 data points. So it's hard to be really precise when we have a fairly small interval. But to interpret this, we're going to do something very similar to what we've done with previous confidence intervals. We're 95% confident that. And then we want to talk about the parameter. So the parameter here is the population slope. We're 95% confident that the population slope is in this interval. All right, and one more thing before we move on. Is it safe to make cause and effect conclusions based on this data? So I would say no. And that's based on the study design, not the p-value, right? The reason we say no here is because this is an observational study, not an experiment. So when you have observational studies instead of experiments, then it's possible that we can have confounders here. So maybe at the same time that they were increasing their spending on direct mail, they were also doing other things that boosted their sales, right? There could be other things that are actually causing the improved sales here. So remember, just calculating a p-value or a confidence interval, that's not going to determine your scope of inference, right? How far you can actually extend your conclusions is also dependent on the study design.